Everybody had that. The answer is 10. Everybody had the right answer. It is 27. All right. For those that missed it, did you do this to come up with a 4, square it to get 16, and then multiply by 3 to get 48? You got to keep that 48, and then over here this is 3, square it to get 9. 3 squared is 9, not 6. So 4 times 9 is 36, and then you have the minus 3. Just go left to right and come up with 81. Pick a number from 1 to 5. The winning number today is 3. Homework check. It's the assignment after you finish the pre-test. We have 7 here. 7 had homework. 100%. Very good. Here are the answers. We'll go through the right and wrong first, and then we'll answer questions after we figure out what we missed. You can check these all at once. Here are the pre-test results, and I'm going to show you the results from this class and from the other classes as well. The high score in this class was Johnson, and the top 4 that get homework passes will be Johnson, Darnell, Bartley, and Ruark. Salyer's tied in the last place there, so we have actually 5 people that make the top 4 scores. Fourth period, the high score was Kleiber, and they had 10 people that could have had a homework pass because they have many more than you guys. More people in class. Kleiber, Bruton, Clark, Owen, Stickler, Webb, Hellier, Kegley, Imes, and Hamilton. And for fourth period, the scores that we had there, the highest one was 36, and then it went 34, 34, 32, 32, 32, 30, 28, 26, and 26 for the top 10. Fifth period, the high score was Baldridge, and their top 10 would be Baldridge, Blizzard, Boyd, Armstrong, Hammond, Bailey, Perry, Montavon, Garrett, Carver, and Blevins D. Notice they have 11 because they had the same situation you had. There was, at the bottom end, there were a tie for those scores. And for fifth period, the scores that they came up with were, the highest one was 46%, and then it goes to 44, 40, 38, 36, 34, 30, 30, 30, and 30. Today it's a new objective. Creating equations. Create equations and inequalities in one variable and use them to solve problems. Include equations arising from linear and quadratic functions and simple, rational, and exponential functions. Here's an example. There are 60 students going on a field trip. Mrs. Hickman's class has 17 students, and Mrs. Bentley's class has 25 students. What equation can we create to solve for the number of students in Mr. Royce's class, who is also going on the field trip? So we've decided to let X represent the number of people in Mr. Royce's class. And then once we have that X, remember we're going to have an equal sign for our equation. Where should I put the X? Yeah.
Like on the very end of the equation, like where you get your answer.
On the right side?
Yeah.
Okay, so we'll put X there. And what can I put for the 60? Where can I put the 60 at? Yeah, we can put it in the front. And what would I put next?
Minus 25.
Minus 25. And then what?
Minus 17.
Minus 17, that's right. That would work out. Here's another one you could also use. What about x plus 17 plus 25 equals 60? Would that give us the same result when we go to solve for it? Yeah. All right. And we're not going to solve these for a specific answer right now. Remember, the objective is to create the equation. So you could have had the one in red or the one in green. Example 2. There are, and the word are is missing, there are 115 students from 3 classes that will eat in the cafeteria today. Class 1 has 43 students. We do not know the number of students in Class 2, but it has half as many students as Class 3. What equation can we create to represent the number of students in Class 2? We can put 115 on the left or the right? On the left side? Okay, we'll put 115 on the left. Now what are we going to do? How many classes do we have? We have 3 classes. And what would we do if we knew the number from each class? What would we do to find the total? If we knew all the numbers for the 3 classes, you would add them together, yeah. So if we have 115, 115 would have to equal all 3 of those classes added together. You would have Class 1, Class 2, and then Class 3. If I could add all those classes together, I would get 115. Is there any class in there for which we know a specific number of students? Which one? Number 1. So we can start with that. Class 1 has 43. All right, what do we know about Class 2?
It has half the amount of students as Class 3 has.
Yeah, it has half the amount of students as Class 3. So in other words, Class 3 has how many students in comparison to Class 2? Twice. It has twice the number of students. So what can I let Class 2 represent? X. Yeah, we could put X in there. And we know that it has half as many students as Class 3. So that means we know Class 3 has twice as many. So what do I put in there to represent Class 3? What would I do to Class 2 to get Class 3? You would multiply it by what?
2.
By 2, yeah, because Class 3 has twice as many as Class 2. So what would I put in that blank for Class 3? Not x to the second, but you would put a variable in there. That's right, you would put x, but what would you do to it? Yeah. That's right. You would have to multiply it by 2 because it has twice as many as the number of people in Class 2. So there's an equation, and the only thing you could do to this equation to simplify it right now would be x plus 2x. What's x plus 2x? If I have one x and I add 2 x's to it, I have how many x's? 3. So 115 equals 43 plus 3x. If you left it like this up here, we could still take it. Okay, we have 3 buckets that contain apples. Bucket 1 is unknown, but we do know that bucket 2 has twice as many apples as bucket 1. And bucket 3 has twice as many apples as bucket 2. If there are 70 apples in all, then what equation can we create to represent the number of apples in each bucket added together? So we have a total of 70. We know we have to get a sum of 70. And how many buckets are we going to add together? 3. So there's bucket 1, 2, and 3. Alright, so Bucket 1 is unknown. If it's unknown, we can start with X on that one. Now, what is bucket 2 in comparison to bucket 1? Times 2. So what would I put in here to represent bucket 2 if it has twice as many as bucket 1? 2x, right. Now we go to bucket 3. Bucket 3 has twice as many apples as bucket 2. So here's bucket 3, and it has twice as many as this one. So what would I do to bucket 2 in order to get bucket 3? Bucket 3 has twice as many as bucket 2, and here's what we're letting represent bucket 2. It would be 4x because you did what to it? You have twice as many, so you multiplied it by 2, yes. So there's bucket 1. Bucket 2 has twice as many as bucket 1. That's why we multiplied it by 2. Bucket 3 has twice as many as bucket 2. Bucket 2 is already 2x, but we still multiply it by 2 to get 4x. Now, if you had that, that's one possibility. Another is that you simplified x, 2x, and 4x. If you add them all together, you come up with how many x's? 1 plus 2 is 3 plus 4, 7. So you could have had 70 equals 7x. This has a coefficient, which is a number multiplied against it, of what? What number is here but it's not written? 1. So you can't forget that when you go back through to add, subtract, multiply, or divide. 1 plus 2 plus 4 would be 7. A class of 30 students is going on a field trip. There are twice as many boys as there are girls. What equation would let us represent this scenario? A class of 30 students is going on a trip, and there are twice as many boys as there are girls. So we have 30 altogether, and what two things are we adding together to get 30? Boys and girls, yeah, so we'll put boys here, girls there. And we don't know boys and we don't know girls, but we do know there are twice as many boys as there are girls. Here's a tip for you to use in the future. Look at this sentence. There are twice as many boys as there are girls. As there are implies that this is what you're acting upon, like you're multiplying the number of girls by 2. So if that's the case, whatever you're multiplying, tripling or whatever, that's what's going to be your variable. So you let girls equal x, and then to get the number of boys, you would have to do what to the number of girls? Multiply it by 2, so we should put a 2x there. You could also have 30 equals 3x. Mid-class quiz. Just come up here with the solution. You don't have to write out the equation and just show me that. Come up with the actual answer if you can. The sum of 6 and the quantity squared of the difference of a number and 2 is 22. Alright, the sum of 6, that's going to be 6 plus the quantity squared of the difference of a number and 2 is 22. Is means equals. Ah.
So the answer was in.
Okay. I see what you did there.
Well, we have to still solve it though. So when you're going to solve this, you have your 6 plus over here. Take that away from this side. 22 minus 6 is 16, and then you're left with this on the left. Now something squared. Don't worry about x minus 2 right now. Just think something squared is 16. What would I square to get 16? 4. I would square 4 to get 16. So whatever this is in here must equal 4. I'm going to end up with a 4 from this and square it to get 16. So that means x minus 2 must equal 4. What would I take 2 away from to get a 4? 6, yes. The product of 5 and the difference of a number and 11 is 25. Find the numerical answer for this. Alright, the product of 5 and the difference of a number and 11 is 25. So I have to multiply 5 by something to get 25. What do I multiply 5 by to get 25? That means this whole quantity here is equal to 5. X minus 11 must equal 5. And to solve that, you would move your minus 11 to the right and make it plus 11. So x would equal 16. Example 3. A group of 76 people are going to tour a factory. No more than 20 are allowed to tour the factory at any one time. What inequality would best represent the number of groups that would have to be formed? Yeah, we have 76 people, and if we divide that by 20, we would come up with an answer, or not necessarily an answer, but a number of 3.8. That's a start, but remember, what inequality would best represent the number of groups that would have to be formed? What we don't know is that how many groups, the number of groups, that's going to be the variable. So we'll let x equal the number of groups that have to be formed. Notice we have an equal sign in here. What could we replace the equal sign with, since we're looking for an inequality? Think of it like this. We have x for the number of groups. X is the number of groups. Could x, and you have to think in terms of an inequality, could x be greater than this amount? No? Would x have to be less than that amount? So if x were going to be less than that amount, would I put an inequality sign pointing to the x or with the mouth open to the x? Yeah. Alright, if we divide 76 by 20, that amount should come out to be less than. Could it also be equal to the number of groups? So 76 over 20 less than or equal to x. For your homework tonight, here are all of the example problems and practice problems, even if we didn't get to those practice problems. And you have to go through and actually solve for what it's asking for. Not only create the equation, which we already did in class for most of these, but you have to solve for the answer of each one.